everyone, I am Igor Alcantara, and today I am here to talk about the top 10 mistakes in a machine learning project. And, I don't know how many times I heard people saying things like, um, with AutoML tools, I don't need a data scientist. Anyone can do machine learning. Yeah, right, George. Or just plug in the data and the model will figure it out. And yet, 80% of more of these projects fail and people blame the tool. Well, let me tell you what, they're wrong. And this is what I want to briefly discuss in this video. But before I begin, let me make you a promise. If you stay until the end of this video, I will show you exactly how you can move from experimenting with AutoML to becoming truly AI ready. And those are two different things. We all know that Qlik Predict is powerful. AutoML tools, they lower the technical barrier. So then we can have more people build modules. So instead of spending time doing a lot of programming, Python, R, etc., we can focus more on the analytical, the scientific approach of this stuff. So this is all true. Love it. But here's the dangerous myth. If I can click and generate a module, then it means I understand machine learning. That is not true. AutoML removes the coding friction, but it does not remove responsibility, does not remove knowledge. So let's go through these 10 mistakes that quietly destroy ML projects, especially in AutoML environments like Qlik Predict. So let's start with mistake number 1, asking the wrong question. This is probably one of the most common ones. Most failures start at this mistake. People ask, will this customer churn? When will this machine need maintenance? Well, they sound fine. They're like business question, but they are not machine learning questions, and they are incomplete. First, you must understand what kind of problems you're solving, what kind of problems machine learning is solving, and match that with the business questions you have. Is this a classification? Is a binary classification? Is a multi-class classification? It is a regression. It is forecasting, which is something totally different. For example, when will the machine need maintenance could mean 3 completely different modeling approaches. Second, you need to define the time window, like churn, let's say customer churn. Would the customer churn? I mean, yeah, eventually, maybe 10 years, maybe in 1 month, maybe in 6 months. You notice how useless that question phrase like that is? It's useless. Time matters. Okay, churn when? In 30 days, in 6 months, before renewal. Third, and this is where many projects collapse, when exactly will you run the prediction? After 3 months of subscription, then I run the prediction to understand if the customer will churn in 6 months. Okay, now we're talking. Now we have a better question. It's 90 days before renewal. Every month we're running the same prediction. Let's say we're talking about patient readmission. When you're running the module, 24 hours before the discharge, 48 hours before at the time of discharge. And there is like the trade-off on that. So if you do not define the prediction momentum in the life cycle, your module will learn patterns that do not exist in reality. And AutoML tools cannot fix a vague objective. It will only optimize the mistake. Now, moving to the second mistake, confusing machine learning with forecasting. This is also very, very common. A lot of customers come to me and they have like a problem and say, okay, this is great, but this is not a machine learning problem. This is more like a forecasting. So you have certain number and you want to predict what the number will look like in the future. It's basically a forecasting, no machine learning. And it happens a lot, a lot. So forecasting predicts numeric values over time. Like what is the revenue next quarter? what is my demand next week, and classifications. For example, they predict events. Will this churn happen? Is this a fraud? Will this loan be default? So these they are related, but they are not interchangeable. If you use a churn classifier and expect a smooth trend curve, you misunderstand the two. Take the wrong modeling type, and everything after that becomes expensive noise, and the project will fail. And sometimes you overcomplicate stuff because if you need just a simple forecasting, there's other ways to do it. Now, let's quickly move to mistake number three, ignoring leakage. So leakage is when your model sees the future, which in reality we know it's not possible. We don't have a DeLorean. So it can happen in subtle ways. Let's say you include a variable that was created after the event. Let's say you predicting customer churn after 3 months at the customer first subscribed. And then you using variables that are only available 6 months after. So there is future leakage here. Or you include a field that is updated after the event. Or you add variables that will not exist at the prediction time. So all of those means the same thing. That's leakage. So training performance will look fantastic. In training, the model will be amazing because we'll have data from the future. Who doesn't know the data from the future? If you give me the lottery numbers from the future, I'll win every single time. But you know that's not possible unless you have a time machine, which, as far as you know, do not exist. So training, it's amazing. And people say, you see, I don't need a data scientist. Look at this model. I have 100% accuracy. Oh, yeah, right. If that even existed. And then you put into production and you realize that the performance collapsed because in real life, you don't have data from the future because the future did not happen yet. In production, those fields do not exist. And your model highly depend on them, so your model collapses. So your AutoML tool does not understand your business timeline, but it basically trusts the data set that you gave during training. So leakage is very dangerous because it feels like success, but it's a huge failure. It's like an NFL team practicing against a high school team, and then when it goes to actually the real NFL season, it collapses. So same thing. Moving to mistake number four, believing more data means better models. Oh, yeah, just add more data and it will be better. More columns do not equal more intelligence. Sometimes equals more confusion, more noise. There's something that we call the curse of dimensionality. That's basically that. So adding hundreds of features without thinking introduces noise, spurious correlations, instability, harder explainability, complexity, and relevant data beats massive data. And the relevant data, when if you have too much noise, it becomes irrelevant always, 100% of the time. So we need to be aware of that. Now, moving quickly to mistake number five, ignoring bias. Your model learns history. If the history is biased, incomplete, or skewed, your model will scale that bias. Will not fix the bias, will not ignore that bias. So who's missing from the data? Do we have all the data? Do we have the incomplete data that will be important? Why is this data missing? What past decisions shape this data set? So AutoML, Qlik Predict, tools like that, they do not remove bias, as I said. It basically amplifies it, accelerates it, and that's really problematic. Mistake number six is worshiping accuracy. Accuracy is comforting. Let's say, well, I have a very high accuracy. Great. But it's a lot of times useless if it is not understood within context. Let's say, for example, we have cases that are very rare. Let's say 1% of the cases are fraud, and 99% are no fraud. But then you get a model that gets 99% of accuracy. Well, if I basically say nothing is a fraud, I'll still get 99% accuracy because this is a rare condition. So I'm not catching anything. I did not analyze the confusion matrix. I did not understand that with other metrics, with true positives, true negatives, etc. So rare conditions is one example, but not the only one. Often something when this is becomes really problematic, but not only that. And we have situations like fraud, failure, hospital infection, churn, defaulting. Those, a lot of times rare conditions. How do we take rare conditions, train the module, and all of those? So there's a mistake not understanding that. And you must evaluate with the right metrics. So each problem needs a right metric to evaluate. You need to understand those, like when to use precision, recall, AUC, cost impact, and the other ones. So the metric must match the business decision, not your ego. Okay, very important. Mistake number 7, confusing correlation with causation. This is very popular one. Correlation is not causation. But in machine learning, still happens a lot. Feature importance shows associations, not cause. If I'm saying that feature A, it has a high importance in my module, it does not mean that is the cause of that effect. If heavy support usage correlates with churn, it does not mean, yeah, reduce support access. Of course not. It means something else. It means, well, maybe we need to educate users more. Maybe the tool is not working. Maybe something else. Prediction is not intervention. Machine learning finds patterns. It does not define a strategy. We need to move with other tools, other techniques in order to explore that. So that's mistake number 7. Mistake number 8, ignoring explainability. It's the black box trap. If you cannot explain why the module made a prediction, then the module is useless because it cannot transform the businesses. So that's very common in any area like finance, healthcare, public sector, sales, etc., logistics. So Qlik Predict gives you explainability tools. Use them. A model nobody trusts will not be used, no matter how good your AUC, your accuracy is. If you cannot explain it, you should not use it. Mistake number 9 is ignoring drift. So drift is basically when the model or when the data, there are two types of drift. There's model drift, the data drift, but when things change. Because you know what? The world changes. Customer behavior changes, market change, process change. Your model will decay over time, or the data itself will change. So drift monitoring, in which it's available in Qlik, it's a survival tool because it's a huge mistake to think that once my module is tested, is good, is in production, just leave it there, don't touch it ever again. No, you need to retrain, you need to monitor, you need to do all of those tasks. If you deploy and forget, you are running an expired module. It is just expire silently, and then mistakes will be made because after time, people start actually trusting and making decisions with the wrong module, with wrong prediction, wrong explanations. And finally, moving to mistake number 10, believing AutoML replaces expertise. Let's say very clearly, and it's not that I'm trying to protect my job. Qlik Predict, AutoML tools democratizes modeling, but it does not make it trivial. It shifts responsibility upstream, but you still need clear objective, clear labels, bias awareness, metric discipline, lifecycle management, explainability, monitoring. Anyone can generate a wrong model, but very few can generate a model that survives production, that changes business outcomes for the better. So Qlik Predict, AutoML tools, they are very powerful, but they don't think for you. Now, let me deliver on my promise. I said at the beginning that I'll show you how you can achieve that. And at Data Voyages, we just started. And if you're watching this video as we launch, the weeks after we launch, this is still true. If you're watching this in the future, let's say we're leaking from the future, then we might have different classes in the future. But it's something that we wanted to keep going. So we do have now, we offering training, and we started with an in-person training. Check our training webpage, because in the future we might have online training, we might have other towns, etc. But because we want more people to understand AI, to be AI ready, we structure a hands-on experience here. Me and Qlik MVP Mark Costa, who created this training that we host in person, called Qlik AI Predict, Answers, and MCP. It goes beyond machine learning. So it's a 3-day, very immersive training. And right now, the date I am launching this video, we have 2 dates available, both in the US. So we might offer other places in the future. So just check the same website. You can check right here in this QR code right here. I'm not able to point it, but you see the QR code. Go there, you see. So we have end of April in Boston, and then mid-May we have in King of Prussia, just outside of Pennsylvania. And it's not just theory; we actually will build. So we're talking about machine learning. We talk about quick answers and RAG assistance. We're talking about data products and MCP and all of those things. And because it's in person, the seats are limited. This is intentional because the rooms are limited, and because we want you to have the best experience. We want to have like one-on-one personal interaction. So seats are very limited. So make sure you go there and reserve your seat. So you can go to datavoyages.net/training and you see information about our training. Because the difference between just clicking, Qlik Predict, and mastering AI is discipline and knowledge. And discipline can be learned. Knowledge can be acquired. I hope you like this video, and see you next time.